This is 607 properties of exponents. So I'm going to show you why the rule works. You just need to know the rule. So if I take x to the fifth x cubed, notice that these are the same base. If one of them was y to the fifth and the other one was x cubed, you can't combine them. But if the base is the same, what is the rule? So it says, let's figure out the rule by writing out some repeated multiplication. X to the fifth could be written x, 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 right? That's what x to the fifth means. X cubed means x, x, x. Well, what's the shortcut? How many x's did I just write out? I just wrote out 8 of them. So I can really represent this problem as x to the eighth, which is a lot more simplified than x to the fifth x cubed. So it just helps us simplify problems. So the rule is, what did I do? I took the 5 and I added the 3 together. So the rule is, if the base is the same, you're allowed to add together the exponents. Don't memorize it. You don't have to memorize this if you just write out the repeated multiplication and see for yourself what is happening. I have 8 altogether. And the quotient rule is very similar. We're going to write out the repeated multiplication and kind of generate the rule. So this says the product rule: to multiply powers with the same base, add the exponents together. So there you go. You learned one of the 6 rules, product rule. Don't memorize the name of it. Who cares what it's called? Just if you see the same base and you're multiplying, you can add them together. Let me go back to polynomial world. What if I had x to the fifth plus x cubed? Am I allowed to add those together? Or if I had like 3x to the fifth plus 2x cubed? No, those are not like terms. X to the fifth is different than x cubed. I can't add them together, right? So don't add them together, but if you're multiplying, you can simplify them. All right, the quotient rule. X to the fourth divided by x cubed. If I write out repeated multiplication, x to the fourth on top, x cubed on the bottom would look like this. What is anything divided by itself? Close. Cancels, and you get 1. So what's going to cancel? This x with this x with this x. I get 1x left in the numerator. So I'm going to write x to the first, or just x. What did I just do? I took 4 and I subtracted 3 of them, and I was left with x to the first. So you're allowed to take the numerator power and subtract the denominator power. So it says to divide powers, you subtract exponents. Don't memorize the name. Don't memorize the addition or subtraction. You can literally write it out for yourself and see how to reduce it. Because when you have rules in your head, it's hard. And we had talked about maybe using our notes on the part of the test anyway. So maybe you'll have this as a resource. All right, so then simplifying each expression. So all of these are using those 2 rules from the top. So if I have x to the 6th times x to the 8th, what will I have? X to the 14th. I can add together the 6 and the 8. All right, number 2 is a little bit different because you have a coefficient of 3 times a coefficient of 5. Your coefficients get multiplied together. 3 times 5 is 15. Now I have x to the first times x to the 5th. So what am I allowed to do to those exponents? Add them together, right? So I have x to the 6th all together. Can you try example 3 and 4 the same way? And then we can do the quotient rule together. So take 1 minute and try example 3 and 4 if you haven't already. The 6th, 3 times 5 is 15. I would have a to the 6th, b to the 10th, and c cubed. Did we do okay on that? So I think exponent rules by themselves, like if you're just focused on one rule, it's kind of easy. It's when you mix up the rules in your head that it starts to get challenging. All right, so the division is when you subtract, right? If I have 9 of them on top and 4 of them on bottom, I will have 5 of them remaining, right? X to the 5th. Okay, on number 6, I've got a 12 over 8. 12 over 8 can be reduced as a fraction by dividing the 12 and the 8 both by 4. Remember how to reduce fractions? Find the greatest common factor and divide it out. 12, so if I divide by 4, I would have 3 over 2 as my fraction. Some of you, the fraction part's going to be the hardest part, I think. I have n to the 5th over n squared, so I would have n cubed left in the numerator because I have more n's in the numerator. That's going to switch. Does that switch? I guess it doesn't. I guess I left the bigger power in the numerator on every single one of these. All right, try 7 and 8 the same way. Divide your number coefficient and figure out how many of the m powers you have left on 7 and 8. Right? So 1/2. I guess you don't really need the 1, but 1/2. Let's see, I have a total of 7 on top and 3 on the bottom. So did you say m to the 4th, 1m to the 4th, or 1/2 m to the 4th? And on the other one, -8 divided by 2 is -4, or -4 over 1. Let's see, m cubed and n to the 6th would all be left in the numerator. You don't even need a denominator, or you could write it all over 1 if you wanted to. So those are 2 important properties of exponents. All right, so the back of that was just some guided practice. So we'll get into some guided practice either tomorrow or at the end of today. All right, I wanted to jump into 608 so that we've got all the people who are here are going to at least have all their properties filled in, and then we can work on catching up on some guided practice of this tomorrow. All right, this was kind of going to be over 2 different days so that you'd have a day to process the one rule on Friday, and then today's kind of the second set of rules so that you don't cross your wires, so to speak. All right, x squared cubed. So I said write out repeated multiplication rather than memorizing the name of the rule or the rule. What does it mean if you take x squared and you cube it? X squared times x squared times x squared. So you're multiplying x squared times itself 3 times. Well, what would that give you? We just did that rule. What's 2 plus 2 plus 2? X to the 6th. So see how this is a different rule? You're actually multiplying the n times the m this time. Starts to get confusing, right? So that's why if you write out the repeated multiplication, you will not be wrong. So you are going to multiply the exponents together if you have a power rule. You got the product rule, the quotient rule, the power rule, it all runs together. You've got to write out the repeated multiplication to help yourself. All right, so try these. So you're just distributing each of these exponents and multiplying. So x to the 24th would be the first rule right there. So complete 2, 3, and 4. If you need a calculator, use a calculator. Distributing, so you multiply. All right, what would I get, Justice? Number 2, m to the, yep, who knows 12 squared? 144. Did you know that's called a gross? A dozen is called a gross. A lot of times when you're ordering in bulk, you'll get a gross of a unit, a dozen. All right, and then what would you get for number 4? Okay, so p to the 0 power, I could also just write that that's 1. Anything to the 0 power is 1. So if you had a string of coefficients and variables and exponents, this is actually an insignificant term. It won't change the value of the rest of the problem. That part of it will be 1 times everything else. All right, so to me, this is the third kind of different rule. Down here, we start putting together a couple of the rules. This is just the distributive property. If you've got more than one item, you have to distribute it to both of the items that are inside. So I have to distribute this exponent to everything that is inside. So I have to distribute the exponent to the 3 and make it 3 squared, and to the x and make it x to the 6th. What would be a better way to write this answer? What is 3 squared x to the 6th? It's really 9x to the 6th. And the same is true if you have a quotient, you have to distribute it both to the numerator and to the denominator. So what would I get for this example problem? X to the, I'm distributing, right? We just did distributing up here by multiplying. So x to the what? 6 over 4 times 3, right? 12. So it says the distributive rule, if the exponent is applied, it must be distributed to every part of the term. So try distributing it in those 4 examples. So see if you can distribute it to each item inside, including any numbers, coefficients. All right, so we've got x cubed and y cubed, right? They both get distributed, x cubed, y cubed. All right, what about this? So I've got 2 squared, and I'm distributing the 3. So I actually will have 2 to the 6th power, because 2 times 3 would give me 6. Then I have 3 to the 4th, but I'm multiplying that times 3, 3 to the 12th. This would be great to do out on a calculator. Did anyone do it on a calculator? Oh, you got it? Because I don't know what it is. It almost doesn't sound good. So 2 to the 6th, 2 to the 6th times 3 to the 12th. 3 to the 12th is a huge number. It probably is going to come up as like overflow. 2 to the 6th times 3 to the 12th comes out as, is that what you said? Oh, okay. How much is that? 3,401,000. Oh no. 2224. I should have said 34 million. Oh, big number. 3,401,2224. So I would just leave it. We're just practicing exponent rules. You can do that one without a calculator. So we're just practicing distributing it. Even when it's a constant, you can leave it as exponents there. All right, this one, what's 1/2 squared? So 1/2 times 1/2 is actually 1/4. M squared would be the answer. So you're squaring the 1/2 and you're squaring the m. Both terms get squared. Or you could write it as 1/2 squared times m squared. That's the same. And then this would be what? B to the 8th and then c to the 24th power. Did we at least get number 4 right? 4 to me is kind of one of the easier ones. When it's numbers, it kind of gets jumbled up. All right, so there's a couple more rules on the back. And then we can do some guided practice on this next class, and I can come around and check off a lot of missing work for you guys. All right, the negative exponent rule. The general rule is you flip it upside down. So a negative exponent gets flipped upside down as the reciprocal. It says y. So it says, let's simplify the following using repeated multiplication and canceling. All right, a cubed, a to the 4th, a. That's what repeated multiplication is. Cancel, cancel, cancel. What do I have left? I have a left in the denominator, though. So if a is in the denominator, you need 1 over a to represent that it's in the denominator. So this says, hey, let's simplify using the quotient rule. What's 3 minus 4? 3 minus 4 is -1. So if a to the negative first and 1 over a have to be equal to each other, isn't that what I just set up here? Flip it over. So if you had, this is a hard one. I feel like negative exponent rule you haven't ever really seen before. 45 to the negative first power is just the reciprocal 1 over 45. X to the negative second, 1 over x squared. So you are unhappy where you are, you move to the denominator or the other place, and you make it a positive exponent, make it happy. So it says when something is raised to a negative power, you flip the line and change the sign, right? So flip, I flip it over and I change the sign to a positive exponent. So let's practice flipping these over together because some of them, when they're in the denominator, get complicated. 8 to the negative first would just become 1/8. There's no negative number written anymore. So make it positive, put it in the denominator. Same thing with number 2. Make it positive, put it in the denominator. Number 3 is in parentheses. That whole thing is going to move to the denominator. So you'll have 1 over 3m. The 3m gets moved to the denominator. What about in example 4? This 4 doesn't move, but the c to the negative 3 does move. So the 4 is going to be left happy in the numerator. C cubed is going to move to be happy in the denominator. I think of positive exponents as happy exponents. All right, this time on number 5, the 1 is happy. Leave it alone. But what about that negative 2? This guy is unhappy in the denominator. You're going to move it to the numerator, right? So the answer is just going to be positive g squared. I will not have anything left in the denominator, so I don't need to write the denominator. All right, number 6. This negative sign is fine. It's just meaning the answer is going to be negative. I have 2x. That's a positive exponent. Don't move it. The only thing that needs to get moved is this guy, right? How do I make this negative 4 happy? Move it up to the numerator. So my answer is going to be negative 2xb to the 4th, all in the numerator. I don't need a denominator anymore. And that rule we'll definitely practice tomorrow. All right, and then the last rule on the page, the zero exponent rule. Anything to the 0 power is always 1, and it says, why is that? If I simplified by canceling, what's a over a? So we just said anything divided by itself is what? 1. So see how a cubed divided by a cubed canceled and gave me 1? Well, what was the quotient rule? Take the 3 and subtract the 3. Isn't 3 minus 3 0? So doesn't that mean that a to the 0 power does have to equal 1? So mathematically, for our rules not to fall apart, anything to the 0 power is 1. So guess what? Anything to the 0 power is 1. Anything to the 0 power is 1. Anything to the 0 power is 1. Down below, say it with me. Anything to the 0 power is 1. Anything to the 0 power is 1. So if you've got a parenthesis and it's the most complicated parenthesis in the world, but the exponent is 0, save yourself all of the simplifying and just write equals 1.